There are three reasons why we need to implement proper system controls in any process. The first is stable operation. This includes any environmental and safety standards that are set by the government or EPA. Any process must meet these standards. The second is product specifications. This is so your company can maximize the quantity and quality of their product. And finally, we need to maintain homeostasis, which is to allow your system to respond quickly to any fluctuations such as temperature and pressure. This is an example of a runaway reactor that resulted in an exothermic explosion due to a lack of automatic control systems. In this batch reactor, the temperature rose above the maximum safety level. This was due to two reasons: excessive heating from the stream inlet and insufficient cooling from the coolant. This was due to a result of manual valves in which the operators were slow to respond in time. This can be solved by implementing automatic controls that can respond instantaneously to fluctuations in temperature and pressure. The result was a runaway exothermic reaction that blew the top off the reactor and created a 100 city block radius of contaminants.
This is an example of a proper control system design for the reactor in our example. As you can see, there are three controls on this system. The first is a level control. This controls the plug valve of the reactants, being sure that the reactor does not overfill. There's a pressure control, which is in charge of making sure that the pressure in the reactor does not go above the vapor pressure of the maximum operating temperature. If it does, this will open the pressure relief valve, alleviating the pressure and making sure the reactor does not explode. There's also a temperature control. This is located in the middle of the reactor, and it is in charge of the valves on the steam and coolant inlet streams. The steam inlet stream has a ball valve, and the coolant inlet stream has a butterfly valve. If the temperature is too high, the ball valve will close, and the butterfly valve on the coolant stream will open to the correct position, allowing the reactor to cool down. If the temperature is too low, the coolant stream will close, and the steam inlet will open, allowing the temperature to rise, and the reaction can take